Hello class. Today we're going to talk about the key features of functions for this graph that I made up. But I'm just going to go through kind of the domain, the range, the x-intercepts, those kind of things, just to kind of give you a reference point for everything that we're doing in here. So let's first start with our domain. So domain is the set of all of our x's. So what we want to do is we're going to look from the left side to the right side to find the domain. We're going to put this in interval notation. So what we want to do is start looking over here at the left side, and it looks like this is going to line up with -3 for our x value. So remember, domain is a set of all of our x values. And then I'm going to look all the way to the right. We're going to assume that this is going to keep on going on forever. So that's going to go to positive infinity. So the way that we're going to write the domain is, since this is an open circle, we're going to put a parentheses. So we're not going to include that point. But we're going to go from -3 all the way over here to the right to positive infinity. Okay? And remember, we always put a parentheses on that positive infinity because we can never actually reach infinity. So it's going to end up being parentheses. So we cannot put a bracket on that one. All right, as for our range. So range is the set of all of our y's. So we're going to go from the bottom to the top. And so what we're going to do, if you look here, this is our minimum point down here. So that's going to be at -4. And then this also goes on forever as well. It's also an open circle down here. So we're going to have a parentheses, and then that's going to go to positive infinity. Again, we put the parentheses on that infinity sign. All right. So for the x-intercepts, remember, x-intercepts is where our graph touches or crosses the x-axis. From here, it looks like we have 3, so we have here, here, and here. We're always going to write these as ordered pairs. So my x-intercept, I like to start with the left and go right, but you can put whatever order you want to. So we've got here -1, 0, so that's going to be my first one. Then we have the next one, so that's going to be 1, 0, and then my last one is going to be 5, 0. So those are going to be my x-intercepts, so it's here, here, and here. And then we're going to go to our y-intercept. So y-intercept is where it crosses the y-axis. So we're looking here, this is a solid circle right here, and it is going to be another ordered pair, so we're going to list it as 0, 1. Remember, that first number is our x, that second number is our y, so we're going 0 for the x value, 1 for the y value. All right, so those are x and y intercepts. Now we want to look at our absolute maximum and our relative maximums. So absolute maximum, that is our highest number over the whole entire graph. So it's the highest point. In actuality, since our graph continues to go up forever, there's actually not an absolute maximum for this one. So we're going to put none for that absolute maximum. But there are a relative or a local maximum, and remember, that's whenever it goes up and then comes back down. And so that point is actually going to be right here. And that's going to be our same thing as our y-intercept. So that's going to be 0, 1. So that's our relative maximum. Same kind of thing for our absolute minimum. It is going to be the point that is at the very bottom of our graph. Now this one's kind of tricky. And I'm going to say this is technically still the absolute minimum of our graph, even though it's not actually there. This probably wasn't the best example to use, but we're going to go with it anyways. So, trying to think of how to deal with this. I'm actually going to, let's actually just keep it, we're just going to talk about this relative minimum over here. I'm not going to worry about this. I'm not going to do this to you on a test or a quiz. So let's ignore that absolute minimum over here. We'll just say if this was colored in, let's do that. If it was colored in, then we would have -3, -4. So if that was a solid circle, then we would use that as our absolute minimum. So we go -3, -4. But our relative minimum is, remember, the point where it's not the absolute, but it's the other point. So that is going to be here at positive 3, negative 2. And that is going to be our relative minimum. So remember, that's where it's going from decreasing to increasing. That point where it changes, that's going to be our relative minimum. All right, so we got those. All right, then we want to talk about increasing and decreasing. So our graph is increasing if we're going from the left to the right, and it's kind of going up. So basically, as the y's go up, the y's are going up as the x's are increasing, or the x's are going up. So our graph is increasing here over this green section, and it's increasing over this purple section as well. So the way that we're going to write this is we start here at our endpoint, which is going to be a parentheses because it's an open circle. That's at negative 3. Then we are going to go up to our 0. So whenever we talk about increasing intervals, we're only talking about the x values. So my x value is negative 3 here, my x value is 0 right here in the middle. And for this, I'm going to use a parentheses. Now, that's because at this point, it changes from being increasing to decreasing, and at that specific point, it is neither increasing nor decreasing, so we cannot include that point in our graph. We also have another section that is increasing, so we're going to union that. All this union means is that it means or. So we're going to have this section is increasing, or my purple section over here is also increasing. And that's going to be from, we're going to do parentheses because we're not including that point, so that's going to be positive 3. And then it goes on forever to the right, so that's going to be infinity. And remember, infinities are always going to get that parentheses. Decreasing. Decreasing is only going to be this red section that we have right here. So for that one, it's pretty straightforward. So we're going from, remember, we're still talking about our x's, so 0 to positive 3. And what you should notice is that if I combined all of these increasing and decreasings, hopefully it would match up with your domain over here. So we got from negative 3 to positive infinity, and then we have our 0, 3, that kind of stuff. So just a way to kind of reference everything that you're doing. All right, then we have positive parts of the graph and negative parts of the graph. Basically what the positive means is that it's above the x-axis, so my y values are positive, and negative just means that the y values are negative. So above the x-axis is positive, below the x-axis is negative. We're still going to keep it in terms of, it's kind of like increase and decrease, and we're still only talking about the x values. So my x values here are positive above the x-axis. So on the x-axis is neither positive nor negative because our y value is 0. So we're still going to use parentheses to kind of exclude that. So we're going to go from negative 1, which is this point, to positive 1, which is that point. And we pick those two, so it goes up, goes down, it's above the x-axis there. And then same thing over here, so from 5 to infinity, and remember I'm going to union, and then from 5 to infinity, that's going to be where it is positive, okay? Then negative is just where it's below the x-axis. So what we're going to do is look from here, from negative 3 to negative 2. Negative 3, it's a parentheses because that is an open circle. So negative 1. And then parentheses because it can't actually include the x-axis. Then we're going to union that with from 1 to 5. All right, and then parentheses there. Remember, we use the parentheses because it can't include the x-axis. All right, so that's positive and negative. And the last thing we're going to talk about is end behavior. So end behavior is what our graph is doing on the edges. So basically, we're going to think of it as x goes to negative infinity. So that's going to be basically the left side of my graph. So if my graph went forever to the left, we're going to talk about that. And then my other part is whenever x goes to positive infinity, which is the right side of my graph. So if my x goes here, you're going to see this written as y, sometimes there. Sometimes you're going to see it as f of x. That's really bad. Let me redo that f. So you'll see f of x or y, either one, they're kind of interchangeable. They're the outputs of our graph. So if I'm looking at the left side of my graph, it's actually going to end. So this one's kind of weird, and this is the way that we do this, and it's an open circle. So it's not the best, But what we're actually going to do is we're going to say as x approaches -3. Okay, so my x is going to -3. My y is going to go to -4, or my output's going to go to -4. Now, most of the time, you're going to talk about end behavior as it keeps on going on forever. So if this was an arrow, then we would talk about that x as it approaches -infinity. Now, as x approaches +infinity, that's the right side of my graph. That's as my x goes this way, what is my y doing? My y is going to keep on going up because the arrow is pointing up. So the way that we write this is y is going to +infinity. Now, if it were curved down, or it was going down and it had an arrow going down, then we say that y is going to -infinity. So those are all of our key functions. Hopefully that kind of cleared up some things. And that's it.